Hi, hello. I'm Younghae. First of all, I appreciate the committee members, organized members, to invite me. Actually, it's a DDAP, sorry. First time I attended this conference, so I didn't say about, this conference is existing. Anyway, thank you so much to invite me. Yeah, my talk is talking about like atopic dermatitis disease. Maybe most people know that atopy. Yeah. So my talk is very simple. I'm not doing like showing like a deep theory, but the result is simple. I mean, atopic disease is why it's so complicated. That kind of things I try to answer them. The simple one of the answers we got it is multistability. Yeah. But anyway, like my collaborator is Yosek Kang. He's my PhD student, and the other Sang-Yang Kim, Yong-Yun Jang, Eun Lee. These three people are medical doctors, belong to the Gyeongbuk National Hospital. Yeah. Oh, by the way, I belong to Mass Medical Society in Korea. So even I'm Korean, here like I'm also happy to see like a lot of peace, guys in Korean guys. They study nonlinear dynamics. Yeah. Nice to meet you. Yeah. My talk is too long index. So anyway, simply I just try to mention about atopic dermatitis disease. Yeah. You can see is what is atopic dermatitis disease? Maybe it's this is very worldwide prevalent disease. So you can see it's openly see there. Maybe it's your neighborhood also get atopy. I just simply say like I just mentioned atopy, yeah. And but also like why we got atopy? There's too many complicated reasons. Still we don't know. So it's like the name atopy is like just delete it's a topic and then a is not means yeah. This is the main reason why we call it atopy. And also like the medical market atopy is more than $20 billion per year. Huge market. Yeah. But this is skin system is very complicated. You can see like the top is like a skin variable, looks like brick. Yeah, but below this area, too many things in happens. You see like we call it cytokine, but many interleukin proteins, cells, too many things. But still we don't know exactly. Even biologist guys, to know like the dysfunctions, still questions. Yeah. So in experimental, what they do there to study AD atopy. So it's in research we are doing like 3 ways: in vivo, in vitro. Next one is in silico. Actually, I'm doing in silico. Yeah, in vivo, you can see this is mouse. Yeah, and the cut hairs and then like scratching the skin and put like pesticide, and they make an atopy, and then they check like the functions. What kind of proteins I'm activating. In experiment they do like this way. Yeah, but problem is like this way is not good model. So it's to study atopic disease, we couldn't make it animal model exactly. So it's like a human skin. It's a naturally like we also got atopy, but this way is like we are getting some pure information. This is a big problem. So this is one of the weakness part in experiment guys. So it's the other way is now is using in silico. I'm using big data. mathematical model simulation AI, and then we also do like found like a new the factors in atopic disease. Yeah. So yeah, up to now, so we got like the how we get like atopic disease. You can see like the patients come in through, and then like the immune system is activated. So it's AD4 is activated, and then like we have like the kata system is also activated. So this kind of things is usually biologist guy or doctors easily describe. Even like you don't know way, but then easily describe. But and then like we can like mimic like this kind of way. So we also describe like this kind of mathematical model. Actually, this model is not me. This model is made by like the this group. Maybe you can see that? Yeah. Actually, like this group is the Tanaka group is Imperial College in UK. They working this atopy for more than 10 years. So they do like a lot of experimental and they made like this wonderful model. Yeah. So it's important thing is in this model, they use the 3 switch systems. This is big issue. Like one thing is like the one switch is if a pathogen is coming through, our immune system is immediately working. So this one is we call it R switches. So this one is just like there is some like a threshold. So it's after some threshold, it activated. So it's and then like the percent is reduced them. So it's some reason, and then like it going to the switch is off them. Yeah. But the other switch is a very interesting switches. This one is related to the immune system. So first, like this one, this system is the immune system doesn't work. But and then like if like skin is like we harmed and then like immune activating after some threshold, switch is on, and then the problem is never off. So it's immune system continuously working. So actually, this one is like immunological memory effect. So it's some immune is activating, but even like our skin is good better, but still immune is working. So this is bad things. Yeah. So like so this one is they like try to 3 switch system, but 2 system is very 2 switch is very similar one, but the other one is very interesting one. Okay. So here is they use a lot of parameter. Was the actually this kind of parameter you can see like a lot of numbers, but these numbers is not. I mean, it's easily we can get. You know, usually based on like experiment, like Tanaka groups, I mean, showing like some experimental, they decide this kind of numbers. So it's they to make this kind of model. They, I mean, I think like taking some maybe 10 years. Yeah. And then they show like 2017, the Journal of Allergy and Clinical Immunology. This journal is best, one of the top journal in skin journal, dermatology journal. Yeah. They show like this kind of result. I mean, using the mathematical model, they show like 3 things like one. Actually, here is using this model, we can find like 2 fixed points. One is called like recovery. The other one is called like chronic damage. Recovery means like a healthy state. So it's well, our skin is very healthy. But chronic damage is a very serious case. And also like they show like oscillation states. This oscillation means like, you know, like sometimes your son or your kid get atopy. In that case, sometimes like your the kid is much better, but suddenly going to like a bad situation. Yeah. good, better, good, better, like that. This kind is we can like describe like oscillations. And then like interesting is that they also consider bistability. Recovery and colony is combined things is that they call it bistability. So they call it like this kind of things is phenotypes. So it's in this paper they show like 4 phenotypes. Yeah. So very strange things like yeah. And then like after published this paper, my collaborator, actually doctor, stopped by my office, and then like they don't know the equation because they're doctor. So it's they asked me like working together like so it's and at that time we are slowly started this work. So and then I figured out the equations why we got this kind of things like then that time I started deeply this research. Problem is here, like, and then like I found like the Tanaka groups made a good model, but problem is the analysis has problem because they made like this atopic model. This is non-smooth model, not smooth because they use the switch system. Yeah, so it's usually like a smooth system. We can get like several kind of like the dynamical theory, but non-smooth case, the theory is much changed. Yeah, you know, like bifurcation, and so many port style is changed. So the, I think like their group is a bioengineering group. So maybe they didn't know about these kind of things. Yeah. So it's I try to like figure out this system, and then like exactly like if you factor like this system is we can get like a 4 subsystems. So it's a dependent on switch on off. So some switch is on off, and then we can this system is changed to like this way. So it's ongoing, like the system is sometimes they use some subsystem 1, sometimes 2, 3, it changed them. So it's a very complicated systems. Yeah. And then we found like some interesting things like here like the first time like a Tanaka group show like the recovery and chronic damaging and just oscillation. But we figured out like the oscillation is oscillation can be separated two kind of things. One is we call it like OM, the other one is serious oscillation, the other is mild oscillation. So it's OM, OS. You can see like this is two different oscillation systems. Yeah. So, and then like, actually these two oscillation has different meaning because the serious oscillation has a turn on like the immune switches, but the other one is, this one is not turn on like I mean the switches. Actually, the important thing is like that, yeah. Here, like we found like 4 different, I mean, the kind of like attractor. Well, but if you compare like the clinical sense, in the clinical sense, in two like a doctor test like atopy, they use the SCORAD index. So it's they use the kind of 4 kind of things. So it's maybe our funding is well matched like this kind of system. Now, I mean, we also like the patient using patient data. We also compare them. Like, so it's what kind of things happens. I mean, to diagnose that skin atopic patients. So it's, they belong to like first type or second type. So it's, we also apply like this kind of theory, like yeah. So this one is it takes more time because we have to use the like patient data. So it's using data, and then we just want to compare like our result. So and then like the next thing is like if this kind of thing is perfectly right, and then we also developing, I mean, the cure systems. Yeah, because like the dependent attractor, the cure, the Medicare way is much different. Yeah. So detailing, we wanna investigate this kind of things. First thing is we just found like the new oscillation, and then how to use them this oscillation. But we are detailing, we are not discussion. So we use them. Sorry, the Google AI. So it's I mean, it's a dynamical group show like using two parameters. It's like a barrier, the kappa p, and then like immune response alpha. This is a coordination two bifurcation. So it's they show like this kind of way. I mean, the recovered oscillation, chronic damage by stability. But then we are deeply investigate this system. This coordination two bifurcation change like that. So here actually these lines means like the threshold line. So it's using this line, our system, our point is exist or not like that. So it's here two lines depending on oscillation. So actually to develop these two lines, so we have to get like this kind of theory, theorem, yeah. Using this theorem, actually the to explain this theory is much longer because we also have to mention about the functions, unit functions f, but this is maybe it's it takes a long time, so it's, I have too much time, so it's please later if you wanna interested to see my papers. This is slope functions, and then like we are using this kind of function, I mean theorem, and we develop this, I mean numerically found like this two line. This line and this line is we are theoretically easily get, yeah. And then like we finally get like this kind of bifurcation. So it's in this bifurcation is we have like for example, I mean this one is in this part of the reason we have we possibly get like four attractors, four difference. So it's it means like we get like multistability. Yeah. That's like our finding now. So for instance, the step by step, like I just show bistability. Here, bistability means GBHJ, where is G? Oh, GB, HJ. Yeah. In this case, like, we can get like the two kind of bistability. It's depending on like this kind of oscillation. So it's, we can show like this is a Bayesian of attractions. As here, like some depending on initial condition. This one going to like chronic damage. This one going to like recovery station. Yeah. The other one is also like going to recovery and then like oscillation state. Yeah. So it's too many different things it happens. Actually, this one is what means this one. Yeah. Maybe this more complicated. I can show more explain here. This one is we can also show like this. The other parameter regions, we also show like the multistability, but with like three stages, yeah, three attractors. But more complicated ones is like four cases. In the just middle, we can get like the recovery, the OS, OM, and then chronic case. This one is like a Bayesian of attractions. So it means like even like our body system has the same kind of function. Just for instance, just like we have twins. The twins have like same biological functions, but so it's the depending on initial condition. They live in like some dirty place. They live in some clinic place, and possibly some. I mean the atopic disease can evolve like this different ways. Yeah. So it's this one depending on like here is the P means like the environmental factor. So this is the load of pathogen. Yeah. So it's B means like the strength of like the skin. So it's even like same reason like that. Depending on environment, the skin. I mean the skin disease can change much changeable. Yeah. So it's please like keep like your skin cleanly. It's must better way. Yeah. So actually, like now, what are we doing? Yeah, here is too many cytokines. Yeah, and then like actually we are doing is like we just wanna make new mathematical models, including these things like. So it's uh, here is you can see iron. Iron means interleukin. This kind of protein is we have number 1 to the maybe 300 something like that. So each protein has different functions. Typically, we know like interleukin 1 is much better, but interleukin number 4 is a very bad like in atopic disease. So it's we have too many things connected. So it's using this kind of things. I mean the molecular wise the network system. We want to develop new, more good. I mean mathematical model like, and then like so we also want to find like some biomarkers to cure like atopic disease. Yeah. This is our main goals like. So, but to make like this kind of model, we have to think about a multi-scale model because like this is protein. You can see like the skin variable, the scale, time is different. Yeah. So it's here is you know, why Tanaka group use them this switch system because like to kind of this kind of like multi-scale model, it's very hard. So it's they just using switch terms. Yeah, this is one of way when up to the now. I mean, describing the atopic disease model. That this model is much best one, uh, very good model. But the problem is their analysis has problems. Yeah, yeah. So it's and then like we like submit like our result to the like a good journal. I mean skin disease journal, but we couldn't hard to I mean get chance because they don't wanna like I mean uh, if our result is published them, I mean they just agree like the analysis is low. So anyway, like so yeah. This is one of show like kind of this way. We just show like the non-smooth bifurcation. Like, so it's here is you can see like a four attractors coexistence. So the other section is two, three, four. Yeah. So anyway, this result is last year we published this journal, and then like my conclusion is just I mean we show like some new bifurcation, new attractors, and then we found multistability in atopic system. So it's now it's we just arrived in starting point in research, AD research. Yeah, yeah. Okay, this is my conclusion, and then I think like the time's almost gone up, so it's. Last one is my advertisement. Our center is also recruiting postdoc. Please, like, if you wanna interest in our center, please like apply to me. Yeah, our center is just focused on nonlinear AI big data, nonlinear dynamics. So it's we are doing now like this kind of things. Yeah, AI, big data, dynamics. Please, like, if you interested in this kind of stuff, I mean, please apply to this center. Thank you so much.
Thank you for the interesting talk. Doc, do you have any questions?
Thanks for the talk. I probably missed your explanation. Maybe in page 9.
Page 9.
And you define some subclass of equations, and there's some, yeah, so there's an arrow, time arrow. specifying S1, S2, etc. I
Yes.
couldn't understand what this line means.
Okay.
So do you turn off and on according these time schedules? Is that correct?
Not time schedule. You know, it's actually like you see, we have some conditions. Depending on condition, the switch is on or off.
All right.
And then like the system is changed.
Okay. Okay.
Not the time. Time goes on, and then I get.
Right. Right.
Yeah. Okay. Yeah.
Thanks.
Any more question? Yeah, I have the simple question. Yeah, that you show the Bayes law of attraction. It means if we can control the initial condition, we can move to the better situation. What could you please explain what is the initial condition in this situation?
Okay. So it's here like the sort of like I have to explain in more detail, but here the equation PBD. P is kind of like a Peterson load. So it's the initial condition is like sometimes like I simply intuitively I explain like a Peterson load means like a dirty place or good place. Yeah, so it's maybe like depending on this situation. Actually, the P means like related to like environment factor. So it's like in dirty place, just simply say like intuitively like, there is a lot of pests. But the good place is the percent is low. And then also like the B means like the skin variability means like some people like the skin the naturally is very strength, but some people is too weak. Yeah. That's like our conditions.
It means one is circumstance, one is the when he births. Yeah. It's not easy to control.
Not control. Maybe God control.
I have one more question. In phase diagram, there are two system parameters. Could you please explain what is the variable? Yeah, in previous slide. The previous phase diagram. I mean, for
you this one.
One more. Yeah, in phase there are two barrier permeability and immune responses.
Oh yeah.
X and Y axis. Yes.
Sorry. Yeah, this is more good one. Is here is kappa P usually like a nominal skin permeability is like kind of like the it's related to like a skin strength like that, like the you know, like sometimes like a moisturizer actually like to measure this kind of the value very hard. So it's doctor just check like moisturizer. I mean moisture, yeah. So it's like this one is kind of related to like this kind of factors. Yeah, maybe more detailed things like it's hard to like, explain because biological things. Yeah, the other one is like you see like alpha I. Yeah. It means like the kind of immune response. So it's that immune response is dependent on, people is much changed though. Yeah. So we see like actually one of our question is like we just mentioned like this kind of value, but we are suspect like maybe usually people around here like that, but it's not proved. Yeah, here is we just use like this kind of numbers, but actually like the kind of average value or some like a variation. About this value, nobody checked it, but some pure result we got it, but you know, like in the world, too many people live with how to check like all of them. So we just suspect like that one. Yeah. Here is a kind of a maybe Superman skin.
Thank you.
Thank you.
Any more question? If there is no more question, thank speaker again.